Hello everyone, hope you're doing and welcome back to my channel. Today we're at day 17 of the November daily Leetcode challenge, and we have a hard question in front of us. I think this is the first time we are having hard question in the November daily Leetcode challenge, but don't worry, this question is really nice. I will not say it is hard, it is on the medium level, but yeah, it really gives you a lot of lot of resources to learn from. Okay, there's something very different that we're having till now in the November daily Leetcode challenge. We did not have this kind of things, so it will give you a lot of possibilities to learn. Okay, so don't worry, it's not hard, it's simple, it's not something big like some very typical algorithm. It's not like that. There are so many ways to solve this. Okay, there are multiple ways to do it. We'll see more than one approaches in this question also, in my video also. At the same time, though it is mentioned hard, but I feel like it is not harder once you like understand the thing. Okay, see, while in the first time, yeah, it will be harder, but once you analyze it, that way, once you code a brute force approach, once you understand what is happening, and then try to simplify the parts, then it becomes a bit simpler for you. Okay, so yeah, in the first look it looks hard, I agree with that. So let us quickly begin with this question. Okay, let me zoom in. It is question 862. Shortest subarray with some at least k. And remember one thing, when LeetCode was new, okay, the first 100 questions, okay, they were called the golden questions because like they were some of the best questions. Okay, so it is one among them. It is within the first 1,000 questions that LeetCode had. Okay, so that is the beauty of this question. First 1,000 questions are always great in LeetCode. Okay, so yeah, it's one among them. So just wanted to make you aware of that. So yeah, let's go to the question. So basically, here we are given a integer array and we are given an integer k. Okay, so these are the two inputs, and ultimately we have to return integer output. Let us see what the question is. Given an integer array nums and an integer k, return the length of the shortest non-empty subarray, okay, of nums with some at least k. So it's very simple. What you have to do for this given input array, what you have to do, you have to return the length of the shortest non-empty subarray of nums with a sum at least k. Okay, if there is no such subarray, return -1. Okay, and they are giving the definition of the subarray here. Okay, so the question is very simple here, but before you think of multiple approaches, let me first show you the constraints. And if you see here, the nums can also be negative. Remember that we have solved this question previously also, means a similar question. See there, in that question all the numbers are positive, so you can very easily think about a sliding window approach, and we have done that question. I remember that very clearly. Okay, I think within this November daily code challenge, or the last 2 days of the October daily code challenge, we did something like that. Okay, but here the numbers can be negative. So since the numbers can be negative, you cannot try the sliding window approach here. Okay, so that is the downtime of that. Okay, and if you see here, one more important thing is this is also very important to understand this. K is only positive. Remember that K is not negative. If K is negative, your solution will drastically change. Okay, in this case, K is only going to be positive. Okay, this will lead us to apply one more optimization to our solution, which I will show in the approach too. Okay, so just remember this part. K, this thing is very important here. Okay, K is only going to be positive. That is one of the very important thing which will lead to optimization in our code. Okay, in the approach too. Okay, and other thing is nums can be negative. So while you are deciding your approach, you have to consider this also. Okay, other than that, if you see the length of the given array can be up to 10 power 5, so we cannot go for a n square approach. Okay, if you think about the brute force approach, obviously it's going to be the O of n square approach. That is, you will take two for loops and you will start from each index and try to see which how long you can go to get a subarray of some at least k. Okay, you can do that. It is O of n square approach. You can try that, but if you see the constraints here, you cannot go for O of n square approach. It has to be either log n or n log n only, or anything below that. Okay, you cannot go for a n square approach here in this kind of constraints. Okay, one thing is very clear, I have explained this also. These are some of the important things that you have to consider before solving the question. Okay, you have to discuss these things with your interviewer also if this comes. Okay, so I am going to discuss my first approach. Before that, I just want to show you how we are doing this. Okay, so this, let us say, is a given input to me. Okay, this is the given array nums. Okay, let me write here nums. Or okay, I'm not writing it, just for your understanding. This is a nums array and this is the k, right? I'm just showing you how I'm calculating the sums. Okay, for that, so if you see here, what I'm doing is basically I am calculating the sum till from the starting from the left till that index. Okay, for example, if you see the first index, the sum is going to be -1 only. If you go for this thing, okay, if you go for this two, the sum is going to be 1. If you go for that, you can call it like a prefix sum basically. Okay, prefix sum including the element itself. Okay, you can call that. Okay, you can name that whichever you name it, it is fine, but yeah, I'm going to get it in O of n approach. Okay, so it is kind of a prefix sum only. So sum of these three is this 0. If you write it here, sum of these 4 is 1, you can write it here, and sum of these 3, okay, sorry, all these 5 is 4. Okay, so what we have to do, we have to find a so, we have to find a smallest, that shortest possible subarray whose sum is at least k. So in this case, if you 3, this is going to be the answer. Okay, this is going to be the answer. So I'm not doing the tracing part. I thought of doing the tracing and showing you, but yeah, I explained it using this itself. So this is how I am doing it basically. Okay, so we will not save it in a list, but we will save it in a different data structure this time. But remember, this is how it is happening. So this is the basic idea. Now tell me one thing. Okay, we'll see the code and then we'll come back to this. Okay. So yeah, in this particular, see, this is going to the approach one here. Okay, it is going to be of O of n space complexity and O of n log n time complexity. Okay, here we are going to use the heap. Why we need the heap? Okay, let me discuss that as well. So why we need the heap at any point? Okay, so see here, basically what is happening is, so see, let us say you are at this point. Okay, you are at this particular point, or rather, I say, let us say you are at this particular point. So if you see here, it is coming as k. Okay, now can you quickly tell me? Yeah. So I hope you're understanding. So this is the num array given to us, okay, and this is the prefix sum of that, okay. That is, if I take the sum of all the three here, I'm going to get this as the sum. Similarly, if I am going to take the sum of these three, I'm going to get this as the sum, okay. So can you quickly tell me, if I am at this particular, that I have considered the whole array, okay, I have to see, ultimate idea is I have to find the shortest subarray whose sum is equal to 4, okay. So the idea here is, what I will do is, once I have here, okay, once I have this particular thing, let us say I am here, okay, I am at this particular index, okay, what is the sum till now? It is 1. Can I subtract something from the previous and get and try to see if it is giving me at least k or not? Why? Because see, suppose I want to know the sum of these two, how will I get it? It is very simple. See, if you have to know the sum of this particular subarray, what you have to do, you have to take the sum of this whole subarray minus the sum of this subarray. I hope you are getting. See, what is the sum of this whole subarray? It is going to be 4, right? And what is the sum of this particular subarray? It is going to be 0, right? You have to write that. Fine. Now see this part here. I am at last index. What is the sum? 4. Now see, I know the sum is 4 basically means like this whole can be answered, as simple as that, right? This whole can be answered. Okay, fine. But I need the shortest answer. Okay. So okay, let me maintain an answer here so that you can understand it properly. So the sum of all this 4 is also coming as 4, which is, that means this array itself is a subarray whose sum is at least 4. Okay. So what is the length of the subarray? 5. 5 is going to be my initial answer. Okay. I will try to see whether I can shorten this answer or not. Okay. So let us see here. I am at this particular index. I know the sum is 4, but can I subtract this? Okay, that is, I am trying to find the sum of this particular part. Okay, so what I will do, same thing I will do here. Okay, this 4, okay, this 4 minus this. Okay, so what you will get, 4 minus of minus 1, that is 4 plus 1, which is 5. That is, sum of these, okay, it is going to be 5. Just do it once and see for yourself. The sum of this is going to be 5. And what is the length of this? Length of this 4. So I will update my answer to 4. Okay, as simple as that. Next, so now this part is done. Okay, this part will be removed now from the this from my I'm using basically a heap here. From my heap it will be removed. Okay, next what I have to do, I am here. Okay, so again the sum is 4. Next I will try to see the one element below that, that is 0 here. Okay, what is, see, minus 1 is the smallest here. Okay, then other, after minus 1, what is the smallest one? It is 0. I will have to do with 0. Okay, that is 4 minus 0, which is again 4. That is, this particular subarray is also going to give me the same answer. What is the length of this? The length of this is going to be 2. So I will update to my answer, as simple as that. Okay, so that is how the solution is going to work basically. Okay, I explained that, and now I'm going to show you the code for that. So what we are doing is, okay, if you want to see the output, maybe that also I can show you, so that you have understanding of what we are doing. Okay, so see, I am going to use in this particular question a heap. Basically, what is a heap? See, heap, you must be knowing, there is something called as a heap sort and heap. In this case, I'm going to use a min heap. Min heap, all it will do is, it will give me the smallest element, okay, that we have seen till now. That is the smallest sum that you have seen till now. Why do we need it? So if you have seen here what I'm doing, see, once I have this particular, okay, let me zoom in once. Yeah, once I have this, basically, okay, I need to know which thing I should subtract, okay, from this particular 4, so that I can get a 4 again, or greater than 4, okay, greater than equal to 4, okay, at least 4, right? So for that reason, here I can get minus 1. Okay, remember, why I'm subtracting? See, I am finding the sum of the of element in the subarray using a prefix approach. That is, if I want to know the sum of these two elements, what I have to do, I have to find the sum of all of these, that is, sum of all of these elements, that is 4. Okay, and then sum of the first three elements, which is 0. So if I subtract 4 and 0, I'm going to get the sum of these two. Okay, that is the sum of the elements in this particular subarray. The same thing I have to do. So, but remember, once I have this 4, okay, I am here, I have the 4. I need to know what should I subtract, so that I can get a sum which is greater than equal to 4, right? So in this case, I'm subtracting my sum. Why? It is the smallest element. It is the smallest sum that we have seen till now. Okay, after that we have to subtract 0 and so on. So to get the minimum element, I'm going to use a heap in this case. Okay, so that is the basic idea here. Okay, let me zoom out again, and yeah, So that is what is basically I'm going to do. Okay, so in this case, if you see, we are so heap, what it will is, it will always return the, that is the zeroth element of it will always have the smallest element. But remember, heap only ensure that you get the smallest element in the zeroth place. After that, you will not be getting the shortest element. So if you see here, basically this is not a sorted order. I'm talking about the first element. Okay, so see, each element here is basically, it consists of two elements, but you have to see only the first element here. Okay, so this is basically heap. If you see, you have to just compare the zeroth element of each. It is not sorted, because see, after minus that, what is coming, 3 is coming. You should not have 3, basically you should have -5 first. Okay, instead of 3, you should have -5 here. So what I'm trying to tell is that when we are using a heap, what you have to understand is that heap will only keep the smallest element in the zeroth place. That is, -31 is the smallest that we know for sure. Okay, but if you have to get the second smallest element, first you have to pop it out, and then you have to again check the zeroth index. Okay, that this is something that I want to tell you, that you don't do the mistake here again. Okay, so let us quickly see the solution now. So this is approach one. I will coming to approach two also, but see this first. So I'm declaring the min heap here. Okay, I am, yeah, taking current sub array sum as 0. I am declaring my answer and initializing it to the float, and then I'm using heap and doing a heapify. The heapify doesn't, it's not needed basically when the heap is empty, but yeah, still I'm just doing it, so that you, when you are doing it, you get to know that what is being done. Okay, next, what I'm doing. But just remember, this is a hard question. You have to bear with me, because there is so much to explain. That's why I'm, even I'm touching the smallest of the points, so that you don't make that mistake. Okay. So what you have to do next? As simple as that. Every element you have to add to the current sub. Okay, this one, current sub array sum. Okay. Once you have done it, what you have to do? You have to see whether the sum is greater than equal to k or not. That is for the whole array I'm checking. If it is so, what you have to do? So that means, without, I'm, that is, I'm taking the whole array as it is. Okay, till that particular index. I'm taking the whole array as it is till that particular index. I'm not taking sub array as such. I'm taking the whole array to that particular index. Okay, so I'm just updating that. After that, I will start finding the sub array part. Okay, that is, I will take a sub array between the given array. Okay, for that I'm using this. Okay, what I'm doing is very simple. I'm ensuring that my heap is not empty first of all. Then I'm checking the minimum element in my heap. Okay, if you see here, basically what I'm appending, see, this is append operation. Okay, so every element in my heap is going to be like this. Okay, first element will be the sum, and second element will be the index at which the sum is appearing. Okay, so I make this one very clear. First, that zeroth index is going to be sum, and the first index, okay, in that particular element is going to be the index at which it appeared, that sum appeared. Okay, so that's why I'm checking 0 of 0. That is, I'm checking in the min heap, the zeroth element, I'm checking what sum appeared. Okay, if, okay, just a second, I'm checking what sum appeared. Okay, in this. Okay, if after subtracting the smallest element sum from a current subarray sum, if it is greater than equal to k, that means we have a possible answer. We have a possible answer which is better than this. Okay, we have a possible answer. So what I will do, take that element. Okay, that is, this is going to be my answer, right? This is going to be my answer. This is initialized with infinity. What I'm doing, take the minimum of this previous element, that is whatever the previous value it had, take the minimum of that, comma, I minus the index of it. Here, remember, we took the zeroth one. Here we are going to take the first index of it. Okay, what is the first index? First thing is the index at which this sum appeared. Okay, so basically we are trying to do a sub array. That is, I am doing 4 minus 0, which basically means that I am taking the length of this sub array. Okay, that is the basic idea here. Okay, I'm, this will give me the length of the subarray. Okay, for which the sum is going to be greater than or equal to k. Okay, that I'm going to append here, as simple as that. Okay, now you will ask me why I am doing a pop. Okay, I see, if I do a pop, the idea here is that element will be lost. Okay, so as I mentioned you in the previous one also, see, if you have to keep getting the lowest element, what to do is you have to pop it out first. Okay, only after popping the first element you will get the next smallest element. Otherwise you cannot go, see, this is zeroth element. If you go for the first element, this will not be the second smallest element, remember that, in a heap. Okay, so you will have to pop it first. And one more thing is, see, because this is going to contribute an answer, remember that, that is why also I'm popping it out. Because remember that, for example, let's see here. Yeah, by the way, like, see here, so let us say this. Okay, okay, yeah, this two array constitute for the answer. Okay, remember that. So what I will do is I will pop out -1. Remember, the popping out basically means that, see, once I pop it out, for example, let us say this array also forms the answer, and this particular array also forms the answer. Okay, but we need the answer with the smallest sum or smallest length. Okay, so smallest subarray length. So if this is the answer, that's why I pop it out, so that the next answer that could form will have the smallest length. Okay, that is also a reason why we are popping it out. We are not leaving it like that. We are popping it out. Whenever this condition is satisfied, we have a possible answer. We are popping out the smallest element. Okay, we are not remaining that, we are not allowing to retain. Okay, we are not trying to retain it in the heap. Once we are popping it out, yeah, then first, finally, you see, while this we are coming out this value, what we are doing, we are doing heap push here basically. Okay, this whole element is being pushed the current sum. So once we come out of this for loop, basically, if you see, we are returning the answer. If it is not -1, we are returning the actual answer. So this is the output for that, if you see. and this is how it is happening. Okay, so I can give this output to you. You can just go and check it out. Yeah, as similar as that. So idea is very simple. It is taking the smallest element. Okay, so the see heap push takes of and log, that is log n time, and similarly pop also takes log n time. Okay, yeah, means see pop you can get the zeroth element in over one time, but after that the heap has to be maintained, right? The maintenance property happens and log n time is taken for that also. Okay, so see this heap is being used to find the smallest element, that is the smallest sum here. Okay, for example, I know the sum is 4 here, I need something to subtract from here, so I can take the -1 here. Okay, why -1? Because it is the smallest, so I'm getting this, I'm getting it to the heap. So I hope you understand why we are using heap here. Heap we are using because we want the after we want the smallest sum to subtract. Okay, that is a negative most sum to subtract, or the smallest possible sum to subtract, so that we get a, we get the smallest possible subarray. Okay, as simple as that. Okay, so that is the basic idea. But see, there are many limitations of this heap. Basically, we see after I subtract -1, I will be subtracting 0. Okay, this is the second smallest. But what about this one? This one is remaining as it is. But this is not the right thing to do. If you are going to subtract something from 0, then this also should be removed. Basically, why? See, 0 after we are subtracting, what is the use of this then? Okay, what is the use of this particular element then after all? Okay, so there is no use of this element, because if you are having 0 here, then why you need to have 1 after that? Okay, so that is again a challenge. So the idea here is heap is going to give me the smallest element, but it is not optimal. Okay, that is, we are not removing the elements properly, that is, it is retaining the elements, which is, increasing space complexity. Okay, so that is one thing. Okay, and if you see the space complexity here, it is often why we are using heap as small as that, because this heap in the worst case will have all the elements. Next is time complexity. Why? See, it is a, this is for follow for, it will be often time, and we are using here, pop and push operations. Okay, push is for sure there, pop will be there at sometimes. Okay, so the idea here is again taking log n time, so that is why n log n time. Now coming to the better optimal solution, which is this. Okay, which is this. So in this, what we are doing is, see, the idea is very simple here. Again, what we are doing here is, see, instead of keeping a heap will give me the smallest element. What I'm doing is, I don't want a heap as such. Okay, let me quickly bring the output so that it gives you a better idea. So in this case, I will not keep the heap, I'm just keeping a queue. Okay, in that queue I will be appending the sum of all the elements. Okay, that is the prefix sum, basically whatever you're calling it. I will be inserting this, but at the same time I will be removing them also whenever it is exceeding a particular property. Okay, you'll see that how it works. So here I'm not using any heap or any sorting. Basically, if you see here, we are not doing any sorting here. Okay, so that is why if you see the time complexity is improved to often. Okay, you'll get to know this how it works. So we are basically using a Dequeue. The advantage of Dequeue is that, see, when you append an element or a pop element from the end, then it is fine. But when you insert element towards the left, that is the zeroth index, when you pop element towards the zeroth index, then often time complexity is used in case of other arrays. Okay, list or anything else. But if you use a Dequeue means it's a double-sided queue. Okay, so in that it is optimized for this operation. You can insert and up, that is append and pop from both the ends in O of one time. Okay, so that is the advantage of it. So what we're doing, we are doing the same thing here. We are appending this, and then we are checking. See, this is part also same as the previous solution. Okay, I'm not explaining this for, I'm not spending much time here because it is same as the previous solution. Yeah, then comes the most important part. Okay, while queue, okay, it is checking whether the zeroth element, okay, whether the zeroth element, after subtracting this, whether we are getting k greater than equal to k or not. If we are getting this, what we are doing, the same thing here. We are doing a pop of left. Okay, we are popping it from the left. Remember, in a simple list, if you do a pop of left, it will take off on time. But since it's a Dequeue, it will take off on time for this. Okay, and we are calculating the minimum element as such. Okay, this part is very much similar to the heap part, but the time complexity are different. Remember that. Here what we are doing, here we are not sorting. Okay, the left element, the zeroth element here need not be the smallest. Remember that it need not be the smallest, but still we are finding it if it is satisfying this. That's, remember, whenever this condition is satisfied, we are going to get a possible answer. That need not be the smallest answer, but we are going to get an answer. Okay, that is the reason that once it is used, you have to pop it out. Because see, for ith element, let us say the distance of the first element is 2. When we go for I plus 1 element, the distance of the same element from the starting is going to be 3. So since we already have an answer with 2, we don't want the 3, so we are popping it out. Okay, as simple as that. Now we are going to use this, this particular thing. Okay, this is why I spent much time in the starting to explain you why we are going to use this. Remember, k is positive, k is not negative. Okay, so for that reason, we are now going to add optimization. What is that? See, this is needed since k cannot be negative. Okay, what we are doing, see, what I'm trying to do is, whenever I'm going to append a sum, okay, whenever I'm going to append a new element to my queue, I will check whether, and from the last element onwards, I will check whether the existing elements in the queue have a sum greater than my current sum. Okay, so I will pop them out. That is, I will not allow them to be in my queue. Okay, if you see here, basically, if I can show you the right approach for this. erratic number. So yeah, see this case here. So if you see here what it's showing, see for the 0th element the sum is minus 34. For the first element the sum is 3. Okay. For the second element the sum is 54. See, we are not sorting, right? This is not sorted. Okay. For the third element the sum is 57. Okay. Now for the fourth element the sum I found is 45. Now I'm going to append 45. But before appending, what I'm going to do, I'm going to remove these two elements. Why? Remember, their sum is greater than 45. So what is the use of having them? See, when I go forward, what will happen? I will try to subtract it from 45, right? See, if 45 can, after subtracting a sum, that's the the just imagine the elements after that. Okay, if 45 is giving me a sum greater than equal to k, okay, then why should I have these two? Because they are much farther. Okay, they are much farther. Okay, at the same time they are much bigger also, so there is high possibility they will not allow the difference to be greater than equal to k. First thing. Next thing is they are far. So if I have 45 which is at 4, okay, so think about the elements towards right. Okay, so they are first of all far and at the same time they are bigger. So what I will do is I will remove all the elements which are greater than 45. So these two elements will be removed. Okay, then 45 will be inserted. Okay, this is one of the optimizations that we are doing it here. Okay, so this is this part. So what I am doing, once I am checking the last element of my queue, if that is the sum is greater than the element that I'm going to insert, the current sum that I'm going to insert, I will pop them out. Okay. Then I will be inserting the current element sum. Okay, this is the element to be inserted. Okay, the sum and the I. Next, this is another optimization. What is that? See, the idea is very simple here. See, once you see here, no, nothing is sorted in this. Okay, if you see, this is the 0th element sum, this is the first element sum, this is the second element sum, and so on. Okay, nothing is sorted here. Okay, either we are popping it or it is left as it is. Okay, so what now I'm going to do is see, let us say I have seen what initially it will do. It is infinite. Okay? It is infinite initially, but what I'm trying to do is that if the length of q is greater than the length of the shortest subarray, that is c, whenever a new element is coming, what is going to happen? Basically we are trying to see whether after we'll subtract this first, then we'll subtract this. Okay, that is we are going to subtract minus 34 from the array sum, current subarray sum, and then we're going to subtract 3 from the current this one. Okay, this variable is there, right? Current subarray sum. Okay, we are going to subtract all this from that. Okay, but remember what I'm going to do is, see, once I have an answer, okay, let us say here I got an answer of 2. Okay, here at this place I got an answer of 2. The idea here is any, see, the next answer could be smaller than 2, right? Smaller than which is 1, right? So why to have elements? Okay, that is when I'm at the ith position, I should not have more than 2 elements previous to it. Okay, I should have only 2 elements previous to it. I should not have more than 2 elements previous to it. Okay, that is the reason why if I have an answer, once I have, see, initially it will be infinite, right? Initially it will be infinite. Once I have an answer, what I will ensure is for any element after appending this element, I will ensure that I only have this much elements left in my queue, so that I can do this operation in the for the next element. Okay, for doing the next operation in the next, when the next element comes, for doing this operation, I want a very limited elements to be there, because already I have an answer, right? I have this particular thing as my answer, so the next answer should be at least less than that, right? I don't want any answer which is more than that. It's of no use to me. So for that reason, what I'm doing is I am, see, once I append the current sum to the queue, I am doing is I am ensuring that the number of elements left in the queue is not greater than this. Okay, not greater than this. Everything here I'm doing a pop left of them. Okay, remember I'm doing a pop left, not pop right here. Okay, here also we did pop left. Here also we are doing pop left. Remember that we're not, but yeah, appending will be from right. Okay, and this particular part is also, see, pop. This particular pop is also from right. This append is also from right, but here I'm doing a pop from left, here I'm doing a pop from left. Okay, as simple as that. Okay, so this optimization, why it came, see, here it came because k cannot be negative. For that reason, we are ensuring that whenever I'm going to append a subarray sum, that is current subarray sum, every element which is toward the left, which is greater than that, should be removed. Okay, this first thing. Other than that, this is the second optimization. What is that ensuring? It is, remember, even LeetCode doesn't have this optimization, so I am giving you something that even LeetCode doesn't have. Okay, so please pay attention, that it's really going to help you. What this optimization is going to do, this is going to ensure that, yeah, once we have an answer, we don't want the elements to be more than this. Okay, as simple as that. For example, sum is, that is the answer is 2. That means next answer can be 1 only, right? So for that reason, what I'm trying to ensure is that I don't have for any current element I should not have more than previous two element. That is I minus 1, I minus 2. Only these two elements should be allowed. Other than that, everything should be popped out from the left. So this is what I'm doing basically. Okay, and finally I'm printing this for you. And yeah, once I come out of this particular for loop, what I'm doing, yeah, this is the one. I'm checking whether it is still infinite. We're still infinite. We have written minus 1, because if you see in the question, there is no such subarray. You have written minus 1. Ultimately, you have written this particular subarray. Okay. So, upon that was all for today. This is the bigger video, but see, when we're using DQ, the profit here is that, see, every element, see, at most every element will insert only once in the queue. Do you agree with me? Yeah. And it will be removed only once. So on the max, you see, okay, and the insert will be open operation, the removal will be open operations, okay. Removal and append will be open for each element, okay. So at max we are doing n number of inserts and n number of pops. So that is why they are not going to include in the time complexity. Okay, remember, pop and append in DQ are O of one time, so they are constant, so don't have to include them, okay. But in case of heap, they were log n time, so we had to include them. So that is the reason why the time complexity is now improving to O of n, okay. So this was the second solution. I can give the solution in the comment section also for you. It is a really nice question. Let me tell you, that is so much to explore here, and we did so much optimization. And remember, some of the optimizations even LeetCode doesn't have. Okay, even LeetCode doesn't have this much optimizations. So, but I am giving you that. So yeah, friend, take use of this, make use of this. Okay, these things you won't believe now, but let me tell you that these things are going to help you a lot in your interview. And if you can do this kind of optimizations in the real interview, I'm telling you, you will be selected, because no one could have thought of this kind of optimizations. Okay. So often that was all for today. If you like my words, please to subscribe to my channel. I know this is a slightly longer video, but I'm trying to give my best to you so that you have every possible resources freely available for you. So often that was all for today. See you tomorrow. Thanks a lot.